Like this, I'll M1 S1, M2 S2, M3 S3. Let it be T. I'm going to mix them all. Then I'll get a composite mixture. So this will be again temperature of that M1 plus M2 S3. Let it be temperature of mixture will be T, that one only. So in that case, what we write M1 S1 T is equal to M1 plus M2 plus M3 into S. So what is S is equal to? In case if you want to find out specific heat of mixture, you should think in this way. So what is this? Specific heat capacity of mixture. Okay, like this also you can find out. May not be, okay, at our level, we are not bothered about all those things. Just I gave one formula. So what all our numericals, heat gained by a body is equal to heat gained is equal to heat lost. And nothing but what is this? This shall we say conservation of energy principle or conservation of mechanical energy. So what is this equation correspond for? Shall we say conservation of energy principle? Almost all your numericals revolve around this particular thing, conservation of energy principle. Now let's take some problems on this. 2 or 3 problems will do it. So there's a liquid A having a mass m, temperature 12 degrees Celsius, -19 degrees Celsius, 28 degrees Celsius. When A and B are mixed, temperature will be 16 degrees Celsius. Similarly, when B and C are mixed, temperature will be 23 degrees Celsius. So what will be the temperature of mixture when A and C are mixed? Is asking to calculate that T. All are having same mass. Different liquids are there. Of equal mass are at temperatures 12 degrees, 19 degrees, and 28 degrees. Can you hear me?
Yes, sir. Now
Yes.
yes, sir.
Now can you hear me? Yeah. No power. Okay, fine. Yeah, we'll continue. He's asking, find the temperature. Mixture when A and C are mixed. Different liquid means what we don't know. We don't know their specific heat. He has not given information. So he's asking when A and C are mixed, what will be the temperature of mixture? What is 16 degrees? There's a mixture of A and B when A and B are mixed. I think here also you have to draw a diagram. See everything. You open textbook, you have equations. At least student can draw small diagrams like this. Liquids are there. Okay, now I am going to mix. Okay, what actually here? So not understanding this. Go to the kitchen. Go to the kitchen. Okay, purchase Pepsi, some cold drinks, milk, water. Okay, this will be cold drinks. This will be milk, water. You boil it to temperature. Start mixing them. Equal proportion. Take thermometer, 80 rupees thermometer. Do that and come back to physics class. Finish all. Okay, now how to calculate the temperature of the mixture A and C. In physics, if the college were open, if it were in physical classes, no, by this time I think everyone would have got beatings. The online, okay, you are luckily got like a somehow survived. I usually I'll come with a stick. Whenever very good concepts are there, students unable to think, no, I'll come with a stick. I think by this time everyone would have got nice beatings. Luckily you are in online class. Okay, now what to do now? How to? There should be any method. So here first we'll do one thing. First A and B, well, they mix up. No, we'll see what actually happens. So M into SA, temperature of mixture. So heat lost equal to heat gained. That's the thing. So who will gain heat? I'll start with an when A and B are mixed. Now heat gained by A is equal to heat lost by B. What is the heat gained by A? Mass into specific heat, 16 minus 12. Heat lost by the B, mass into specific heat. Heat loss means initial minus final. So this will be 4 SA is equal to 3 SB. Now, similarly, when B and C are mixed, heat gained B and C, heat gained by B is equal to heat lost by C. Heat gained by B, mass into heat gained by B, SB. What was the temperature? 23 minus 19. Initial 28 minus 23. This will be 4. 4 SB is equal to 5 SC. Similarly, we'll start with this one. When A and C are mixed. When A and C are mixed, so who will gain it? A will gain it. So let me write directly, or also like a heat gained by A equal to heat lost by C. Heat gained by the A, mass, specific heat of A. Temperature we don't know, T minus 12. Agree this. Then M into SC, initial minus final. Is asking that T. For that what happened, we don't know SC and SC. So this will become SA now. What to do? SA and SC. I'll substitute 1 and 2 in this equation. So in place of SA, shall we write 3SB by 4? In place of SC, 4 SB by 5. Solve this, you'll get T. Anybody value?
20.25.
Not understanding, purchase one thermometer, 80 rupees. You'll be having water, milk, or any other thing. Have 3 different temperatures. Nowadays, we have even the measuring instruments also. You can measure weight. Sir, how to measure this in a container? I think that common sense you must be needed. You fill up this liquid in a polythene bag, then mix up in some vessel, or mix up them in polythene bag. Will you get exact answer practically? Will you get slightly different? Anybody wants to answer? Anyone wants to reply? Will you get exact answer in practice if you do in your home, or will
No,
you
sir.
get any reason?
Some heat will go to the atmosphere, go to the environment.
No. Usually, where do we mix up? In air can we mix up liquids? Next topic I'm going to start. Okay, more practical knowledge is needed. Okay, in air can we mix up? In vessel. Okay, fine. In vessel. What vessel I should pick up? You instead of putting chat box now, you can directly talk with the teacher. It'll be better.
Insulating. Heat insulator.
Heat insulator. Huh?
Yes, sir.
What are the examples of that vessel? Can you give?
Thermoflask.
Thermos
Thermostat.
flask.
Thermostat. Thermos flask. Okay, in kitchen, do you use that to mix up?
Sir, conductors. Sir.
Tell me, like in kitchen, I think you will be definitely mixing many things, no?
Sir, in heat
So,
conductors.
thermos flask, shall we use that for cooking? No, we never use, no, only to store something, no? We never use thermos flask to mix something so that no heat, nothing. So it's a thermos flask, take it out. You are in paper world, be practical. In kitchen, okay, be there. Okay, you want to mix up 2 substances which are a different temperature. Tell me what will you use? Polythene bag? Will you mix up in air? Will you use thermos flask, or you'll use just steel containers? What all copper, steel, brass vessels are there?
The steel
Steel
container.
container.
Steel containers you'll use, no? That is a quite natural, no? Okay, now. What is the problem we are going to face? Even that steel container also will absorb some heat, no? Will agree this? The same thing if you go for industry, I'll manufacture some syrups. I have to manufacture at what happened initially when I produce it, no, they'll be at 300 degrees Celsius. It should be mixed up with another which is at 100. So where I should mix up these 2 syrups? Then the proper composition means once the cough syrup especially, what happened, one chemical will be at 300, other chemical will be at 100. When I mix up at that temperature, the composition then reaction will occur, then we'll get the original thing what we needed. Where I should mix up these 2? You should answer me. Shall I do that in polythene bag? No. Shall we do that in wooden vessel? Because somebody said like a insulator should not absorb heat. wood will also absorb some liquid. No, it is having a property to absorb because it will wet. Most of the liquids will wet the wood. Means definitely the wood will absorb some. And cleaning that will become big problem. Anybody uses wooden vessel in kitchen, in
No,
your
sir.
room? No, we don't use wooden vessels. No, not advisable also. And then next. So what is the best thing vessels which I should use? Okay, it's the mud pots in villages or in most of the town cities. What people will go for the vessels made up of metal, copper, iron, or steel is the best example. So even in industry, if I want to mix up two liquids, I'll use the steel vessels. Fine. So now what is the problem? So let's get into the realistic world. So in books we have a theory. I could have just discussed theory, but you'll find very easy. So I have a milk. Like a 1.4 kg of milk. This is at temperature